Okay, good news about this last section. Special products have some fun little tricks that we can use in order to quickly simplify these type of binomials into polynomials. So like last section, we are going to be focusing on multiplying binomials, but the binomials in this section have special outcomes. Let's find out why they're called special products by simplifying the following polynomials. Well, last section we understood that if we are multiplying by a binomial, we do have to distribute both terms through the second polynomial. So let's go ahead and do that. We have x times x, which is x squared. X times 3 is a positive 3x. Multiplying that negative 3 through, negative 3 times x is negative 3x. Negative 3 times a positive 3 is a negative 9. Last step then they say is to combine like terms. So we have a positive 3x and we have a negative 3x. Those guys cancel out. So we're not going to put any x term there. We're just going to say x squared and we're subtracting 9 from that. So notice what happens. Like I said, most of the time multiplying a binomial by a binomial gives you a trinomial. This time we actually just had a binomial. Why is that? Well, let's look at the two binomials we multiplied together. They are opposites. So notice first term and second term are the same, but the sign is changed. So when we look at this rule, we are going to say when binomials are exact opposites, the outcome will be different. We see that, but what's different? Well, let's compare x to x squared. It's the square of x. Would you agree? 3 squared is 9, so it's the square of that number. So the outcome will be the first term squared and it's always going to be minus, and I will explain that in just a minute, minus the second term squared. And the reason why we're always going to be subtracting there is that if they are opposites, a negative times a positive is always going to give us a negative. Okay, so here's the question. Do we have to have that memorized and say, oh, they're opposites, I know it's going to be that squared and that squared? No, if you want to just drill and practice and distribute this out, you're still going to get the answer. But again, these are just nice little tricks that we can use. So binomials are exact opposites, which means I have x's, I have 5's, I have opposite signs in the middle. I know then it's going to be the first term squared minus the second term squared. So I'm going to plug in an x here. I'm going to plug a 5 in there. And I'm going to go ahead and simplify that. X squared is x squared minus 5 squared is 25. Simple as that. Okay, understanding why that's special. Those are two exact opposites. So let's go ahead and try that for 3. Again, 4x, 7, 7. I have opposite signs, so I know it's the first term squared minus the second term squared. And I'm just going to fill in the blanks. 4x squared minus 7 squared. Okay, notice how this is a little bit different because I do have a coefficient on my x. Remember this 2 then affects both of those pieces. So what is 4 squared? 16. What is x squared? X squared. Minus what is 7 squared? 49. So that is the trickiest thing here. Remember that that square does affect the 4. This is not 4x squared. This is 16x squared minus 49. Okay. Okay, so that again are exact opposites. Now let's look at how 4 through 6 are a little bit different. Here we have x plus 6 squared. Okay, so what does that mean? Well, we understand that when we're squaring something, that's the factor, that's 2 factors of that product. So x squared would be x times x. X plus 6 squared would be x plus 6 times x plus 6. Biggest mistake I see students do with this is they're like, oh, well, I understand that that 2 is going to affect both of those pieces. Not when we are dealing with a binomial. When we are dealing with a term, when we are multiplying, yes. If we are adding and subtracting, no. That means that we are taking the whole binomial and we are basically doubling it. So let's go ahead and see what happens. We have x plus 6 times x plus 6. Okay, going to do my distributing. While I'm doing this, do you think things are going to disappear? Okay, think about that and why or why not while we go ahead and simplify this. I have x times x is x squared plus the 6x, and then distributing here, I have plus 6x, and then 6 times 6 is a positive 36. Okay, let's go ahead and combine some like terms. I have twin 6x's, so I have an x squared plus a 12x plus a 36. Okay, so we didn't actually get rid of anything there. Okay, so we do still have a trinomial, but let's look at what kind of trinomial we have. Okay, we squared that first term, so look at that, we have an x squared. Notice how we actually squared the 6 as well to get a 36. Where does this 12x come in play? Well, notice that when we distributed this out, we combined two twins of those two together in order to get a 12x. So we doubled the product of both of them together. Okay, so when multiplying exact and twins, and I'm going to say that and say like binomials, you're going to take the first term squared, add double the product of the two terms. And I'm going to explain this in just a minute. And add the second term squared. Okay, so like last time, do we have to have this memorized? No. You could actually distribute out exactly like we did and still find the answer. But these are nice little tips and tricks. So again, looking at that x minus 8 squared, I know that I have exact twins. I have like binomials because I'm multiplying them by itself twice. So how I would set this up if I wanted to learn this new tip and trick, I would square the first term. I would add that to double the product of both of them, and then I would add that to the last term squared. Okay, so a little bit more in depth than what we did with the last section, but let's go ahead and try it and see if you like that or not. Come on, move. I guess it's not going to move. Okay, so first term, x. I'm going to double both of them, so I'm going to double an x and a negative 8, and I'm going to add that to negative 8 squared. So I'm going to go ahead and fill in the blanks. X squared, I have a 2 and a negative 8 and an x, which gives me negative 16x. Negative 8 squared is a positive 64. So look at the pattern here. If I'm using subtraction, my middle term is always going to be negative. My outer term is always going to be positive. Always. Because if you are adding negative 8x plus negative 8x, it's always going to be negative. Any negative number squared will always be positive. Okay, so final answer. Again, do you have to do that? No. It's just a nice little trick if you are good with formulas. Okay, let's do one more. Again, I see that these are like binomials, so I'm going to square the first. I'm going to double the product of the last, or the two terms together, and then I'm going to square the last. And I'm going to see what we get. So I end up with 3x squared. Here's my first term, and my second term, and then my second term. Remember, if I have a product of a coefficient and a variable, that square does affect both. So I have 9x squared. I have 12 times 2, which is 24x plus 16. Okay, again, that formula is a little bit trickier than the one that we just used with the difference of squares. Okay, those are the type of vocab words that we're going to be looking at. We realize that these are the difference of squares because our outcome, each piece is going to be a square, and then we are subtracting, so it's a different. These down here are called the square of a sum or the square of a difference. And again, that's what we're going to work on in this section. So go ahead and get out the notes and vocab for this section. Okay, objective of this section is to multiply two binomials, just knowing that these are actually special product type of binomials. Again, they give their example here. We talked about it in the introduction. One comment that I want to bring up is that this step right here shows how to use algebra tiles. Algebra tiles are amazing for students that really like hands-on type of work. However, that is a whole separate, like 4 chapters. I do have algebra tiles. I have some really great books that coincide with algebra tiles in order to, especially starting right here in the chapters that we're going to go into, algebra tiles are really great to move around with. Also solving equations. So if you are interested in that, go ahead and get my contact information and give me a call. I'm not going to be using them, unfortunately, so if I could share them, that would be great. So again, these are called algebra tiles, really great for hands-on type of work. Okay, otherwise, square of sum is what we're going to work with. They do a good job here with symbols, explaining what I showed you in words. So if you like those symbols a little bit better than how I explained it, go for it. Otherwise, we're going to look again at our rule. Okay, we have two like binomials and we are squaring it. So we understand that again, I'm just going to put big parentheses where they did, and I might as well color code with theirs. So I know that I'm going to take my first term and I'm going to square it. Then I'm going to add on 2 times that first term times the second term, and I'm going to add that on to the second term squared. Okay? And remember that this only works if they are exact twins. So here's a 3x, and here's a 3x, here's a 5, and here's a 5. There's our little formula. Now let's go ahead and just simplifying it, realizing this 2 affects both pieces. So we end up with 9x squared. We have 6 times 5, which is a positive 6x, and then a positive 25. Whoa. Okay, I should have stopped me again. Yes, 6 times 5 is a positive 30x, and then a positive 25. So again, what did we do? We took the square of each piece, which is 9x squared and 25, and then we doubled the product together. So 15x times 2 is 30x. Okay, so without the formula, if you can do it that quick, looking at it like that, go for it. Otherwise, formula is really nice to use. Okay, go ahead and try guided practice 1. Okay, these two problems have 2 variables in them. So when we got to that middle one and we doubled the terms, we have both a C and a D variable. Rule is if we do have more than one variable, we usually write them in alphabetical order. Okay, so this is actually in standard form because again, even though we have 2 degrees here, C is before D in the alphabet. C is before D in the alphabet. So that's why we wrote it like that. Okay, remembering that we distribute both of those. Same thing for 1B. I was going to mention, remember why we double this. Because again, when we multiply this out, we actually have 2 of the 24 CDs. So this is 24 CD, and if we have 2 of them, we have the 48 CD. Again, really stress the fact that this is 8C plus 3D times another 8c plus 3d. It is the factor of both of them together. You cannot just distribute that square through because we are adding there. Okay. All right, moving on. Now we're looking at the square of the difference. So basically the same thing, but remember the pattern that I talked about, that if we are squaring a difference, our middle term is always going to be negative, our outer term is always going to be positive. So the only difference is that we're always subtracting that middle term. Okay, so again, I'll go ahead and set it up the way that they did. I know that I'm going to be taking my first term squared. Now I'm subtracting twice the product of the first term and the second term. But I am adding that last term. And the reason being is that we're always taking a negative times a negative, which is going to be a positive. A negative plus a negative is always going to be negative. That's why we have a negative and a positive in this problem. So now I just fill in the blanks. My first term is 2x. Okay, my second term here is 5y. So since they took in the fact of all of these negatives, we're just going to put a 5y in here. Okay, I didn't do that in the introduction, but with their pattern, their formula, we're just going to look at that 5y. Okay, go ahead and simplify this down to 4x squared minus 20y, because again, 20xy, because we are doubling those terms, and then plus a 25y squared. Okay, so the only difference in formula is that we are subtracting that middle term. All right, go ahead and give that a practice 2 a try. And there they are. Stressing again that you do not need to use this formula. You can go ahead and distribute them out, FOIL them out, and you will get the same answer. However, these type of concepts are going to show up in next chapter, so we do have to understand what we're doing, the pattern on how to multiply these together. Okay, here's our real world concepts. Again, we're looking at that square, but now we're looking at a square of the difference. So it says each edge of a cube of aluminum is 4 centimeters less than each edge of a cube of copper. We're supposed to write an equation to model the surface area of the aluminum cube. So they said that the edge of an aluminum cube is 4 centimeters less than this cube of copper. Okay, so we're dealing with aluminum, and you're going to bear with my picture here. There's a reason why I'm not an art teacher. Okay, so here's my aluminum cube, because again, we're writing it to model the surface area of the aluminum. This one up here is copper. So here's our copper, and here's our aluminum. Well, they said that this edge is 4 centimeters less than that. So there's our translation. We started with C, and this one is 4 centimeters less than the copper. Okay, so we're looking at surface area. That's a pretty in-depth type of area that we're looking for, but remember that that is just the outsides of this. So I always say it's the label. If this was a juice box, we are just looking at the outside, not the inside surface. Well, the surface area, how many sides do we have? 1, 2, 3, 4, 5, and 6. So we have 6 sides, and we are looking at the area of each of those sides. Well, what's the area of a square? Because since this is a cube, we know that this is a square. It's side squared. Okay, so surface area formula is 6 times the side squared. Okay, well, do we know how long our side is? We actually do. We know that it's C minus 4. So our side is C minus 4. So formula that we're going to use is surface area equals 6 times C minus 4, and that is squared. Okay, so we actually have 2 different things that we're doing right here. I'm not going to look at that 6 just yet. I'm going to go ahead and focus on this. I know that since this is a sum of difference, I'm going to square my first term. I'm going to subtract 2 times that first term times the second term, and I'm going to add on the second term squared. Okay, all of that I have to realize I'm going to take that answer and I'm going to multiply it by 6 in order to get my surface area. So I have C for my first term, and I have 4 for my second term. Okay, again, I'm going to know that there's a 6 out here, but I'm going to go ahead and simplify this. I have C squared minus 8 squared plus 16. Now I'm going to go ahead and multiply that 6 through. Okay, so here we go. Again, we're distributing the 6 through. So once again, we're supposed to write an equation to model the surface area of the aluminum cube, understanding that we're not going to get a very pretty answer, but an equation does have an equal sign and it does have variables, so I think we're getting there. Surface area is 6c squared minus 48c plus 96. And there then is our answer. Okay, showing just how this relates to geometry. Okay, off to guided practice 3. Okay, I really like the vocab of this section. We have a garden that's G feet long and G feet wide, realizing that that actually is a square. They don't come out and say it, but if it's the same on each side, we know that we have a square. He wants to add 3 feet to the length and the width, so translating that over, now it's going to be G plus 3. But this is where I like the vocab. Show how the new area of the garden can be modeled by the square of a binomial. So again, here's our square, and here's our binomial. So understand that that vocab is dealing with the type of products that we are looking at in this section. So that's all they wanted for A. They wanted us to substitute that G plus 3 in for the side. Then we were supposed to find the square of that binomial. And so we used our little formula to do that. Okay, so again, that's the product of the sum of a product and then the difference of a product. Now we are looking at that sum and difference. Okay, again, they show the really cool algebra tiles and how to do that. If you want to get into that, let me know and I will help you out with it. Otherwise, remember this was our formula, that we know that if they are exact opposites, then we are going to take the square of the first minus the square of the second. So looking at that, again, we are taking the square of the first and we are subtracting the square of the second. And the reason why we can do that is we take a quick look and realize that they are perfect opposites. So we are going to say that we are taking 2x squared squared and then minus 3 squared. Okay, so realize again that that 2 affects all pieces. 2 squared is 4. X squared squared is x to the 4th. And we are subtracting 9. Always going to subtract because a negative times the positive is always going to be a negative. Okay, so a little bit different formula because again we are now not looking at exact twins, we are looking at exact opposites. Okay, go ahead and try guided practice 4. Okay, keep in mind that again, do we have to use this formula? No, you could distribute that out and realize that those two middle terms will cancel out. But also remember that this type of concept is going to be used for next section when we're actually trying to solve problems like this. So let's go over those vocab again. This is the product of a sum and difference. Okay, so again, the difference of squares is what we call it. Up here, we are looking at the square of the difference because these are perfect twins, and we are looking at the square of a sum. So 3 different types of formulas that we used in order for us to understand that these are special products and that they can be solved in a special way. Okay, go ahead and try the assignment for this section.